Excellent. It's been a little while, hasn't it? Okay. Oh, well, I better bring up this little console here so I can watch people watch me, because that's always entertaining. Let's just have a look at that. All my little consoles, I put them over there. Excellent. That's just wonderful, isn't it? Okay. Wait a couple of minutes before I tell everyone what I'm up to, but in case people come to join me. But if you're watching the recording, what we're doing tonight is we're going to make kind of an example project which connects specs with Godot. So specs is like a ECS or entity component framework in Rust, and connect that to Godot. So that should be excellent. We're going to do that. So first thing I need to do is get the very latest version. Let's have a look. Everything seems okay with the screens. Get the very latest version of Godot Rust. So let me just bring up a browser. Pull up a tab. Sit down in front of you all. I really should set up so it doesn't show my previous links whenever I open this browser. It's not very professional. Let's see, Godot Rust. That's the one I was looking for. So what I want to do is clone or download this repository. Here is how I could do that. Copy that link, and then we're going to jump across to the folder. I might put it in game dev. I often put all my junk repositories in learning. So let's create a new repository. So I already created one, I think, new repository, Godot Rust specs example. So this example, and here I am making a folder without really thinking that through, because I actually want to type that text somewhere else. So git ext clone. So this is git extensions I'm loading here. I use git extensions to help me manage Git more easily. Oh, I just realized I haven't got my chat window visible. I better move this editor so I can see the chat. In case people... Oh, yay! Hello, Wildly. It's nice to see you there in the chat window, right over there. And also Weak Constructor, good to see you guys. I'm just cloning the Godot Rust repository. So let us proceed. Here in Git Extensions, clone Godot Rust. Destination is going to be in my learning folder. I'm just going to add this last part to the name, which was this crazy thing I just typed in here with lots of minuses in it. I'm going to create that as a subdirectory, and I have to delete this one because it's going to be angry if there's something in the way. Clone! Clone, you good thing, you! Yes, come to me, my precious. Okay. So this is the Godot Rust repository, and if you go in here, there's an examples folder with Hello World, Scene Create, and Spinning Cube. So if you are new to this, I suggest you start with Hello World, and if you haven't already, I understand there's a fantastic tutorial on this, and it's called Godot Games in Rust. It's made by this game Tom, he's pretty cool. Anyway, you should read this. Apparently people like it. So this is a tutorial to help you get started with Godot. So I thought it might be nice to create a second tutorial. Well, I only need one hand for two. A second tutorial which covers the kind of mapping between specs, which is an ECS, and Godot. So like puts the two together. So I've already done this in my own project. If we have a look in here, this is my code. Close all these, close all in group. And if I go into my SG core repository, I've got source, and I've got I probably put it, no, I put it in this thing called components, and I created all these different components that got mapped across. So in particular, if you look at entity move, it actually moves Godot entities to match the 3D position from specs. So this is like really handy dandy. If you've made some specs code that moves things in 3D, it'll sync it up for you. So we're going to be migrating this out of my project into something that everyone can share. So let's just open a new project here. open, and we'll try pointing it at this entire repository, which should work. So the folder we're going to provide is just this one, and I'll get rid of the word examples on the end. That folder. We'll open a new window. So I'll just take this one and I'll tuck it out of sight on this other screen where you guys can kind of barely see it. That one on the other screen is my project, and here's the one we're working on today, which is currently just the repository, Go.rust repository. So let's have a look. Let me just check I've got these all the right height. Yes, everything's lined up across the board. This seems to be lined up with your other screens, so that's good. Let's see. So in examples, we've got these 4 examples. We're going to create a new one in a minute. But let's just try running the Hello World example, which we do by running Godot. And it brings up this little dialog here. And I need to say import. And if I point it at this folder, I'm trying to copy that, point it in here, so import, and then browse from here. And then we go into Hello World. Well, let's actually go into the scene create because that's kind of cooler. Choose the project file, open, import and edit. So let's put up a Godot window. So this is an example project I created some months ago and got in a pull request, got that into Godot Rust, which I'm quite happy with. This one was my last major learning from the bindings, which is how to actually make stuff. So you'll see you can't see anything, but if you add child, oh, I must have a breakpoint here. Oh, something has broken my old example. Non-existent functions spawn 1 in base spatial. Okay, well, let's dive into that problem, shall we? So in the scene create here, oh, I know what's probably wrong. I probably need to actually build, I probably haven't built it before I run it. That's probably why it's not working. Yeah, nice one, Tom. In fact, actually, if I look in the warnings, it's probably in there, output. Yeah, it couldn't open it because it wasn't built. So, great demo. Doing really great so far. Okay, let's have a look. CD this folder. Oh, good. Oh, Wildley's already jumped to the end. He's already discovered that it works great. So it just needs me to push the build button. Yeah. Now, this whole fetching thing that's going on right here, it points to the fact that I probably should set up some local caching. You can actually set up Rust on your computer so that it will cache build results between different projects. I've never bothered to set it up because in theory I don't have many projects, but actually I have lots now. I probably should be caching. So it's downloading all the requirements again. That was silly. So that build process is going to take a little while. So the next thing to worry about is that the different examples that I'm working with, we're going to need different libraries. Most of the examples here do not require specs, but given the title of this talk, you probably guess that this new one's going to. I think in Cargo TomL we can specify this is a workspace that has sub-projects. Oh, and so each example is a sub-project. That makes life easier, I think. Probably. There should be, yes. There's a Cargo TomL. And the reason why it makes life easier is because if you look up there, and my very tiny writing, let me just make that a little bit less tiny. Hold on, settings. Yes. And in the editor, I'm just going to pump up the font size for you to 16 or 17. Yes, there we go. That's probably more readable now. That's up there. So if you look up there, you'll see that it's got the list of dependencies. And the reason why this is important is because we're going to need to add specs to this list for our example. So, libclang didn't compile. And the reason why is I used the wrong target. It's a bit annoying, but on my computer I need to, maybe just for tonight I'll set the example, the default project. So let's have a look at our list of compilers. Rust up. Rust up help. And let's see, I need to see, I thought it was list. Oh, it's show. Great. So these are all the ones that are installed on my computer, and in order to build this, I think I need this one here, the 64-bit Windows MSVC. The reason the other one is the default is because the CLion debugger is very picky about which toolchain you're using. It's quite annoying. So, yeah, I can see that word constructor. It's back now. I was just kind of, yeah. Thank you. Anyway, so we're going to fix this. You can set the default to the one I just copied a moment ago when you weren't looking. Oh no, I don't say set, I say default. So now that target is the default, when I try and do this cargo command from before, it's going to use that particular Rust version, which lovingly has to recompile everything. But, you know, I kind of like that it has to recompile everything because it knows what it's doing, and it's like, oh yeah, if I didn't recompile it, it would like not work. So that's building up there. It's been a while since I last streamed. It's a bit spooky to be watched again. I'm using a transparent mug. You see there's even a little non-transparent tea bag. This is because I've currently got green screen chroma key set up. You can probably guess which colour my mug is. But the specular reflection is not green screened. Anyway, that was so cool. Transparent tea. Which sounds lame because I mean so many cups are naturally transparent. But how many cups do you know have got a sound bar in them? Oh yeah, when I talk, my mug fills with yellow and green. Okay, that's still compiling. So, examples. We're going to make a new example, and it was going to be kind of like one of these scene create ones. So let's just duplicate this. Control C, Control V. We're going to name this one specs integration. Okay. Oh, Widely is hosting me. That's the first time I've ever been hosted. Thank you very much for hosting me. I imagine that means that everyone who's your follower is now being subjected to my crazy. I hope they don't mind too much. Okay. Do I want to add these files to Git? I think I won't right now. Yes, one advantage of adding them to Git is they would have tracking of some kind. Okay. Oh, the build is done. So if you missed it, the reason why we're building is because we're going to run a Godot example just to prove that it can be done. So let's run this Godot again, and yes, it's working now. So each time I push add child here, it's calling some Rust code that is actually creating children in this scene, like so. And I can also remove them. And this is an example of how to create a scene of your own and instantiate it using Rust. And it's one of the examples in Godot Rust. It's called Scene Create, and it's in the examples folder. So if you haven't tried those examples, you really should. So this is the last thing I learnt some time ago. I might have to move my sound monitor bar down to where it's in my tea when I drink it normally, just so you can fully enjoy the drama of a transparent tea bar. We'll put it down here. Okay. Then I don't have to think about trying to show off how cool my bar is. Now, so we're going to create an example like this, but this one's going to use specs. So we'll probably end up using physics too, because that's a nice way to get some behavior. I appreciate the gesture. Don't get too worried about whether it works or not. Okay, specs, that's a response to the text comment by Wadley there about how he kindly is hosting me. Specs integration. So let's think about this for a second. It's not surprising that specs integration is going to require a version of specs. So for my specs work, I'm just going to pull back up my own project as an example. Here it is. So this is the Recall Singularity, which is a game written in Godot and Rust, in which you build factories in space, in little spaceships, and later on you make them to big spaceships. But this is, going to be so great. When it's real. Okay, not just a figment of my imagination. What we're doing tonight is we're taking some of my stuff I've learnt when making this SG Core DLL, and we're going to try and share it with you all. So, with the example on the left, so if you look here, we already have GD native here. See, there it is there. It's from the Git repository that this example is in. Simulation and net and mine, obviously. Rand, Zoshiro, lazy static, those aren't necessary. We actually will need lazy static because we're going to use that. We're going to create a singleton world in specs, so we'll need that. And specs. Not sure if we need crossbeam queue. because I don't know if I want to demonstrate crossbeam here. We'll just take that out for now. Uslid. ND array, don't need that. I use ND array for my floor calculations for like the shape of the ships. To like represent that, I make like a array, 2D array of bytes. And in algebra. Now I feel like there's something missing. Ah, yes. We might bring the physics across as well. But I don't mention the physics in this project, because in this project they're just data. The physics are mentioned in the simulation project. So for that I use specs physics and these. So if we decide to do physics, we'll need those ones here. Everything outside the blue sheet is safe. Ah, yes. Do you want me to get them for you? Okay. There's a very stealthy person in my office right now. Yes. Let's see. Ah. I love you, Shrew.
I don't exist.
Are you a figment of my imagination?
That's right, your girlfriend lives in Canada.
My girlfriend lives in Canada. Okay, okay, it's good to remember. Thank you very much for clarifying that. Anyway, yes, that figment is now gone. Let's see. That's the physics we might use later as an example. I don't know. I think a lot of people would be made very happy if we did use that physics. So maybe. Most people probably don't need physics in their specs examples, so it might make things more complicated than they need to be. Anyway, specs integration. Maybe we should do that for a different example. Child scene, default environment, icon, main, panel, project, scene create, lib. This is going to need to be changed. So this resource here is going to have a different path. Obviously the way this is built is putting it in the root directory. But one thing is it's going to change the name of this to be specs integration. So we'll just change this here. Wow. I find it easier sometimes to change these things in the text file. The editor allows you to change these too if you don't want to do it this way. Shift X, F6 and C-line to rename this file, and we'll paste it in there too. Okay, and in this cargo.toml file I had to specify the same name. So up here, okay, that's the name of the DLL that's going to get created. So that all lines up now. Those names have to match. Who are the authors? So I think I'm giving credit to the original author of the library here. CDYlib means that it's a dynamic library, basically, written in the C style as opposed to one called from Rust. And that's a requirement as well. I couldn't get the editor to let me specify a parent directory of res. Yeah, that's a bit hard to explain. Wow, that's one trippy cup now. Okay. I ended up editing the file. Yeah, I think I needed to use an editor to get a weird path like the one that's shown there as well. Like use a text editor, not the UI one. Okay, let's jump into some Rust code. So the Rust code is in source, and this is not what we're going to want. Now, there's going to be so much source in our example, we probably need to make multiple files. We might even make one per component. I think making too many per component was going to confuse people, so we'll probably just throw them all in the same folder. Hopefully the number of files doesn't confuse anyone. So the components we want, the main ones, there's this one, I've got one here called biped sync. I want entity create, delete, move, and I think move moves in by pos. We'll probably figure out one of those sync states soon. And mod.rs, we'll throw those all across here in source. Oh, it's moving them. I don't want to move them. No. Copy. Good. Okay. So I had to hold down control to get it to copy rather than move. Well, we'll add the original files. Yep. Okay. So mod.rs contains a bunch of my own junk in it. Yeah, weird constructors pointing out where things need to be. I think the examples are kind of allowed to break the rules a little bit. But yeah, weird constructor points out that if you took one of the examples or its weird paths, it might not export from Godot. That'd be interesting. Okay, biped, ship, module. These don't need to stay. So, let's look what I've got here. A template 3D. We're going to need the template to make my old example. GD scene lock here. Let's make a module and call it specs. That might make things easier, hopefully, for people who are looking at this stuff, and then start modifying it to create their own. So, could use this handy dandy cargo crate option and create, well, I don't really want to, I just want a new folder because I want to reuse what I've got. So, directory, specs. No, let's not call it specs. Actually, now that I think about it, renaming it the same as a library sounds like a really difficult situation to be in. We'll just call it sync. Is it complaining now? Yeah, it's complaining because the word specs already turned up everywhere. So, I want to ignore all of this. So we're going to do that rename without searching. No searching for references. Why is it not letting me go okay? And I want to call it sync factor. Great. So get rid of this. So basically when I changed the name from specs to sync, it tried to find every version of specs that was in my code and change it for me to make my life easier, but it didn't really help. So we have a module, a file here called sync.rs, and it's in the source folder. So if we go in here into this lib and we create a mod here, mod sync, it's going to look for the file called sync, and then all the other files that are in the sync directory, move, don't need to search for references. All the other files in that directory, it can see them. So these three, because they're in the directory of the same name, it should find them now. Lib sync, I need a semicolon. Okay, 1 second. Just using it to stew. I'm sure that was highly glamorous. Anyway, let's have a look in here. Create. Mod sync. Why is this not happy? lib.rs doesn't like having a mod sync because it couldn't find it, but it's right there. Oh, no, that's correct. Lib sync. We might need to recompile for this to figure itself out. Huh. Okay, So with that collecting of thoughts done, use uselet vector 3, use those libraries, let's not worry about that right now. This represents some errors, reasons why we couldn't do things. Sing create. Oh, I'm looking at the wrong thing. I'm trying to look at sync here. We got a template, a scene location, which is used for creating some stuff. That's kind of plumbing. So this plumbing is used to help find a Godot node that spatial that we have created in the past. No, it's not what it's for. This is how you specify what sort of Godot spatial you want to create, what to call it. See, okay. The GT spatial is the one that tracks things that have been made. So by implementing a component for these things, we make them into components as far as specs is concerned. We can now store them. We specify how they get stored. Down here, template 3D entity. This is how we specify what things can get made. It could either be a packed scene or a mesh. So we need to know how to make those things. Default is a template 3D entity with nothing in it. We don't need this old register GD floor components, register GD star components. Yep, so that was part of my idea of how my own world works. So register GD components. Let's just do that. And we need a specs world. We don't need a world ID for this. And we don't need we'll just get rid of this brackets. This is all because I use multiple specs worlds in my game, so I need to be able to specify which world ID there is, and I use different types of worlds, sometimes spaceships and sometimes for their content, so I have two functions for the two different kinds. We don't need those in our example. Okay, so that's a sync stripped down. Let's have a look at GD entity create. I'm probably going to need to run some sort of optimizer over this to fix the imports. I know that the tidy that is normally run on this project will fix that. All the code here is like a critical part of the example. I'm not sure why that's not compiling. Delete. I imagine whatever that was is no longer required because it's no longer used. That reminds me. I have a piece of utility code that I use in my code. Where did I put that? It's something I haven't shown on stream yet either. In SG Core, inside of Bridge, I have these. Say for instance the ship link, and it now uses this class called Godot state sync. And the Godot state sync is where in the repository? It's here in components. So I didn't bring that across yet, so we'll just bring that across. Okay. Add. And we'll just need to add Godot state sync to the sync library up here. Not. So lib is the root of this folder. It includes a module called sync, which is this one. And then this one includes some more modules. So we look in a folder called sync, and we find those modules in here. Right, this is how this works. So this name mentions the name of this file. For those people who are really new to Rust, that's what's going on there. Godot state sync is like a little object that contains a bit of our state, and it contains state that we can't store in specs because specs doesn't like stuff that's kind of multi-threaded. It can't be passed between threads, so it's not multi-threaded. It's like the opposite. It's very picky about which thread you use it from. There's a big caveat about using this stuff, which means that in theory maybe we want to make this a unsafe class. But please be aware that you can only use this class that you should only use this class from the main Godot thread. Also note that if a spatial is deleted by other code or scripts in your game, then weird things will happen. So stored here. So there's unfortunately not much tracking we can do with spatials. It's not like a reference counter pointer that we can like check to see if the spatial stayed around. If you create a spatial from Rust, give it to Godot, Godot decides to delete it because the script deleted that scene tree, and then Rust comes along and merrily tries to keep using that spatial. Godot's not going to know what you're talking about. And best case scenario, it'll throw errors and ignore you. Worst case scenario, undefined behavior, which is like everything from crash to format your hard disk. So that's a typical warning. One would say hopefully it won't actually format your hard disk, but no guarantees. So be aware of that. This is like as unsafe as you can be. Maybe I should make this unsafe in the example. This is why all of the Godot Rust bindings are unsafe, because they have these like big limitations. New. I wonder how I can express that warning in a really clear way. Yay. Okay, so in lib, in your own class, manage areas. Lib. Create. So I need to create something here which is similar to. It might actually be that I just straight up use the very same infrastructure I use for scene create, but I restructure it to use specs. That's probably the most clear way I could think of to make this work. So let's take that approach. So scene create no longer needs templates. It might still need to know how many children are spawned. I think that's an important counter as part of, it still needs to know how many children are spawned. Manage errors. How do we use manage errors? It's probably used when we're creating things. Instance scene. Yeah, so let's not worry about the manage errors class anymore, because how we're going to manage them, we're just going to ignore problems, which is like so the best, man. It's probably not a great example. I try to not let perfect be the enemy of good. Like, try not to get so sucked up with making things so really great that I never actually get anything done, because it's so easy to just get stuck. Okay, we're making a specs integration, so let's call this class specs integration. Now, there's some magic here. This GD native class that's highlighted up there, that defined is what makes this all the glue that's required to make this class interact with Godot. So we put that there. And then down here, this GD native methods creates all the methods and does their bindings. So we're looking for these exports. Those ones are seen by Godot. We don't need that. Spawn 1. This here tries to spawn something straight away. This one here only does things if we have a template. We don't want that. Although it does set a translation. So we want to know what the key string is going to be and the X and Y locations. Right? We parent it directly under owner, and we increase the number of children spawned. So this code is going to be critical. We still want that. We don't need this. Let the number of children that's updating the panel, we still want this. Remove one is similar. We need to find out how many children we have. We need to get a particular child. it. We update the panel. Okay. Init is required. Load scene is no longer required. We don't need this. Well, no. Update panel. Need that. Okay, so some of the guts of this example that were from the previous. So it might be worth mentioning in somewhere in here. Demonstrates the usage of specs to manage a scene UI interactions based on, and the other example is called scene create. Based on the scene create example. Whoops. I'm having trouble with my keyboard. Let's try looking at it. That might help. Okay, there we go. Child scene. So, component and specs is created when spawn one is called. Specs components are deleted when remove one is called. Find and call functions in a node panel. Find functions in GD native and panel spawn remove. So we'll add another point to this somewhere. We'll call it point 0, and every frame the contents of the specs world and entities are synced to Godot. This stuff is similar to the other example. What was it called? Specs integration, hello world, secret. Great. So in order to store the world, I've got this Godot sync state thing that knows some stuff about the world, but doesn't actually hold the world itself. We don't need a world ID anymore. Do I need a world ID? Yeah, so world ID was tied to a lot of stuff in my code because it would look for ships and all sorts of things. We don't need it anymore. We're going to strip it out of all my example because don't need to set the world ID. Don't need to get a particular sector. That's a point. I'm going to have to set up a singleton for the world. We don't have to set up a singleton for the world in every game, but if you're using a bunch of Godot objects, you're going to want one. Yeah. I'm going to have to find the original get world mute and set up my own unlocking. So that's to do. What's right to do here because it won't compile world. So that's what we want to call this. So world is a big fat to do. It's going to not compile. If yep, that's fine. That's all fine. World ID. We don't need a world ID anymore. Great. So the GD entity creator doesn't need a world ID. So in my game, the path to the world that gets created changes. The world ID changes, so I don't want that. Child world. So, don't want that. Again, world ID stuff. Don't need to put that in the GD spatial instance. Data there. Instance a template. Cut that out. Okay, hopefully that will do for cutting out world IDs. Man, this code is not perfect. Hopefully it's enough for people to have fun with. Okay, lib. I mean, part of me is just trusting in the goodness of open source, and that I'll put this up and I'll make a pull request, and people will give me some ideas as to how to make it better. And maybe you'll contribute some. That'd be great. And we'll end up with something that we can all be proud of. Okay. So for this example, we will put it in a singleton. Yes, I'm creating an example to put in open source. So I'm taking the stuff that I've learned and I'm trying to package it up into something that I can share. I'm going to make another object just so that I can have somewhere to put a singleton for specs. So let's create a new Rust file. We're going to call this singleton, which I've called it a singleton because that's what I tend to call my singleton file thing. I need to mention it in here. Great, so a singleton file. So yes, no, this is going to be MIT licensed open source. It's going to be part of the Godot Rust project. So when you download that, you will you should find this in the examples folder once the PR is approved. So let's have a look at my own singletons file. In singleton rs, I have a lazy static. Thank you. I have a lazy static, which means it gets created one time. Oh, hello, Tom. I don't think I've seen you on here before. Welcome. I'm going to create a static ref global sector. So it's the global world in this case. Nice. Well, that's great. It's great to have you along. Thank you for visiting. Okay. It looks like Reddit really works. Make sure to push the upvote button. Anyway. Do all the things. Push all the buttons. Okay, we're making a mutex. And inside the mutex is a box which contains a world. And this world is a specs world. So let's just make sure we include that. Use specs prelude all. Just because, we're only using the world right now. But maybe one day we'll use everything. Take over the world. New. Need to make a new world. A whole new world. A whole musical, blah 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 blah. Yeah, so it's a static world, and when you first try to access it, it creates a new one. Let's leave it like that for now. We might use a once. Once is probably easier. Yeah, let's copy all of my infrastructure for creating singletons across, because this is probably useful to somebody. So we create something called a once, which is not related to the Lorax at all. It's not the onceler. No, it's a kind of an exclusion thing that you call one time, and if you try to use it again, it'll be like, nah, done already. I need a function here. I have my init once function. Let's just put this down here. It's going to set up the world. Initialize. I'm going to be renaming some of this stuff, and we'll have a get singleton sector, and we'll put a try get singleton sector too, because that's useful to have. And then these things, we won't call them sectors. Well, maybe I'll do someone a favor, and rather than putting a world in there, We'll put, yeah. Hmm. You might put a whole struct in there because this is an example. It might make your life easier. So let's do that. Make a Rust file and call it your state. And make a struct, and inside that, so the struct is called your state, and hopefully people will get the hint. This is a useful global container where you can put your junk that is later going to be protected by a mutex. Okay, and inside it's going to have a world, which is a world. So that world is the specs world, which is like imagine it as being a list of vectors, each containing components. That's probably, that's my kind of mental imagery for it. Use specs prelude star. It gives us the definition of what a world is. Okay, given your state, we're going to import the your state class. And we're going to make a new function, so pub function new, that creates one of these guys, so it returns one, your state. Not you state, your state. Oh, it says self. And make one, your state. And then let's have a look at my own definition of a world. So I've got two places I create worlds. We'll look at the star one actually. Suppose. And in here, this is how I create my world. So let's pop that in there. Now, most of the stuff that's in there is from my game, so it's not going to be relevant to you. We don't need world events. No, actually, none of that's relevant. But I'll leave one example, so I've got some examples to work with. Registers. Yeah, that'll work. Space state setup, insert. Don't want that. No. For more on how to set up a specs world, be sure to see the specs documentation on docs.rs. Which raises the question, why, if they weren't strange like me, I might write it here. In my project, I register some components in a different crate which provides the game logic. Then I add Godot.tracking components. Haha, I'll just pump myself here, why not? The recall. I might just even put my Twitter link here. Why not? Hopefully, some forlorn soul who needs help will come and find me on Twitter. No, that's not Twitter. Let's try that again. What is going on? Doesn't want to follow the link. Anyway, let me put my so helpful link. It's this one. In my project, which provides the game logic. Then I add Godot tracking components in a different to the world later using some hooks. I wonder if I need another example for that. Yeah, people will probably figure it out. Anyway, so remember, this stuff is dynamic. Yay! Okay. I want to create a new state, your state. I want to pass in a world, because the name world here, and the variable matches the name world here, I don't have to specify anything like world is world. They're both the same, so I can just say world. It's like a little bit of Rust magic. Okay. That's your state. And so, add your stuff here if you like. I'm going to have to have a function that returns a reference to the world. And another one that returns a version that's mutable. And this one returns a reference to self-world, and this one returns a reference to a mutable version of self-world. So that's a nice little your state all ready to go. I just lost it. Anyway. Where is your state? Where did you put your state? Split vertically. There we go. Let's do a nice split and put it over here where you can see it. Ooh. And go back to... So yes, when I was being coached on what to do in streaming, I was told to talk constantly, and as you can see, it comes somewhat naturally. So that's a boon. But I still have to try not to think silently. Okay, your state. That's done. Now my singleton, I want to create your state. So here where I have a mutex with a box in it containing a your state and a mutex new box of your state needs a new your state new. I probably didn't need to specify a type here. I'll take that out later if I remember. And at once. So this is how you set up logging for your project, and it's kind of cool, but it's not the point of this example, so I'm not going to leave any of that stuff in. In fact, what did I leave in? I don't think I needed to leave anything in. In fact, I probably don't need it once now. The reason why I had that stuff in there was to get the logging turned on. So let's just, even though I talked a bunch about leaving that in, we've got this function, this new function on the right hand side of it that creates your own game state now, so that kind of makes the whole once thing kind of redundant, because this code on the right will be called one time when the lazy static snaps into existence. So get singleton state and try get singleton state. And in both cases, they return a box containing your state inside of something called a mutex guard, which, like, as long as it lives, it will hold the mutex safe and warm in its embrace so that you can use it, which is kind of cool. So we'll leave those in singleton. Inside of the lib, I've got singleton here. Still don't understand why it's not happy with that singleton file. Again, I probably just need to recompile and it will sort itself out. Create, delete, move. Yes, so all the entities that are here need to be mentioned. I think I put them in mod. Singleton your state. Sync. Yeah. Register GD components. So there's register GD components, and you pass it a mutable reference to a new world. And it will add the two components that we need to track these things as we add them to Godot. As so. That looks fine. Okay. Lib. So our specs integration requires an instance of your state. No, it doesn't require an instance of your state. It requires an instance of this other class that's here in sync that I called Godot state sync. Let me just put this over here. And so back in lib, I need one of those. This guy tracks. So we just get rid of this guy. Tracks. What does it track? Stuff created in Godot in the past to save the present. Well, yes, that'll probably do. This was renamed. Let's just try and find any more scene creates and replace it with this. So replace, 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 done. Okay. So when creating a specs integration, we don't need template, we need children spawn to be 0. And sync should be a Godot state sync. New, because I think we have a new. Oh, it is a world ID over here, but we don't want those anymore. Let's find all the places where we still have one open. So we don't need world IDs in this code anymore. Don't need that. We're not going to do grandparents anymore. We're just going to take the owner straight away. So that was like this is once again a feature where I used to have multiple. How do we say this? I need an owner. Had multiple worlds being synchronized from specs, and so I needed this concept to permeate throughout. So this parents should just be one parent, and it should be a single reference to a spatial. So we'll just say parent. Oh, we probably need to call it grandparent, not parent. Because parent is where the user can name a node, and we call that, yeah, blah, blah, blah. When we're trying to figure out where we're creating C nodes in, there's something called a grandparent node, and then they specify the name of a parent node, and then they specify the name of the node they want, which goes underneath the parent node. So that's the tree structure we need. In my game, there are multiple grandparent nodes, apparently, effectively. And apparently, because I told you about it. So therefore, apparently I just said that. Language. Okay. You talk long enough, some of the stuff you say is going to be rubbish. Add child. Set name. So, this is how we create stuff. Let me just, we'll just make this little search, so I need to finish a bit smaller for a second. So, when we're creating a new entity, we go in here, we run the system, and we say, for all the entities that exist, right, that have this thing called a scene lock, so we want them to be in Godot. Let's go through every single one. Let's find its current parent, the parent that was specified. So we take the grandparent and find the parent name. And then we try and find the particular spatial and that map of all the spatial entries. And if it doesn't exist, we run this insert code to put it in. And if it does exist, we check its template's okay. Strictly speaking, we could avoid doing this calculation here until one of those two things is true, which would make a lot of sense and save some time. But let that not bother us right now. We don't need set world ID anymore. And then this is a class to create them. So it's another system. Oh, that's right, it's a helper function called instance template. And it will either create a spatial or a mesh instance. I don't think I've tested the mesh one yet. So that's how things get created in this example. I'm kind of starting to feel like it's time to try compiling this thing. So I could run it from the prompt. And what I'd probably want to run is cargo build example and the name of the example, which is going to be specs integration, like this. And it's complaining that there's no, you can read it there, there's no example target with this name specs integration because we haven't added it yet to the workspace in this cargo.toml file. So let's just put that in. Okay, let's try that again. Whoops. That's the one I want. I think what's going on is that Sea Lion, the UI, is currently trying to compile it. No example target named specs integration still. So if we go and have a look at the specs integration target in here and in this cargo toml, I bet I haven't put the right words in here. Is there a look at word for the word scene create? Okay. It might be that I can't use. This isn't actually really technically an example. It's probably a library, because examples are binaries. Lib. What argument do I want here? It's called a package, I think. That's looking pretty promising. Okay, so now that we know what we want to write build minus package specs integration. So we can just take that little prompt, which failed, and let's tell CLine how to do this. So edit configurations. So there's currently none. Add one. We're going to add a cargo command. The name is build specs integration. This is not going to be shared in the repository. This is just for me. It would be nice if it was shared. The command we want is this one, build minus package specs integration, like so. And I believe that's all the things I need to do. Apply. Okay. Run it. Let's run it down the bottom. And it got the very same failure that I had here. So that's a good sign. So let's just put this on the right hand side. Move to... yeah. Okay. Get rid of this find. This feature may not be used on the stable release channel. So the problem we've got here is core intrinsics nightly. I think that if we went into our cargo, we would find that I'm still specifying this nightly feature here. So let's just put both in. If you are on the nightly branch toolchain, consider turning on this feature for nice error messages. Which is exactly what it does. So we don't want any features. No features at all. No, we don't want any special features. We want the standard features, please. Okay, so it doesn't look like I've told the system that I'm using is correct. So in here, we need to add external crates here. Okay, so we're still mentioning this SG simulation, which is no longer relevant. There's a bunch of things here that are from my other example. Create components. We don't call them components here, we call them sync. Template 3D entity, the location, yeah, most of that stuff. Here, it doesn't know what Godot is. That shouldn't be a problem. Okay, so we haven't extern created Godot. Interesting. Did we not say we require Godot here? Does my example have it in, and this one does not? Oh no, I feel the tiredness coming on. It's one of those realities of like working all day and having kids and stuff, is that there comes a certain point where your energy levels go down. hopefully we can push through and be okay. Okay, let's just see if I can figure out where Godot is coming from. SG core, cargo. I must have been mistaken. It's not Godot, it's GD native, and I've already got it here. So why did I say Godot star? Maybe the name of the library's changed since I pulled that in. I'm not sure. Create helper instance scene. Okay, so this is something else from my original, which was I had the way I made things was in this helper class. Let's have a look. Mod. So I have a whole bunch of useful things in here. Triload scene, triload material, instance scene. So what we'll do is we'll grab this helper and we'll put it across and call it helper.rs. This is going to be the most complicated example. .rs add. There's a lot of things in here we don't want. Don't want any of those probably yet. Manage children, mesh placer, don't need those. Godot. They must have changed the name of the library since I last worked with it, so that instead of being called Godot, it's called GD native. So replace Godot with GD native. Let's try that. And it's inside the spinning cube demo. I see. Extern create GD native as Godot. That's what's going on. Okay. Oh, well maybe you said GD native as Godot. Yes. Thank you for coming up with a solution. Thank you. I wish I'd read your comment just a moment sooner. Okay. Speaks integration. So let's change this. Okay. And now GD native is going to be the wrong answer. Oh great. There's so many of them. Yeah, we'll just let the compiler tell us what we got wrong. Unresolved import create helper. Yes, that's right. We need helper. And to get helper, we need to use mod and add mod helper, like so. It's our mod helper. And then in helper, we've got some errors. Got a mesh list, which is like a vector of meshes. I don't think we even need this anymore. Instance scene. Get or add child. We don't need that for this code. Try load scene. We want that. Try load material. We'll leave it in. Load meshes from. It's actually really cool, this function. What does it return? Oh, I see. It puts it directly into a mesh list. What this one does is it loads a complicated scene which has multiple meshes in it. So I've got a scene that has like lots of little asteroids that I made in Blender, and I kept them all together in one scene, and I named them all. And what it does is it loads all the nodes in there, finds them all, and says, you're a mesh, you're a mesh, you're a mesh, you're a mesh too, you're still a mesh, and makes a little hash map with all the meshes in it. It's like a little utility function, which is why it's in helper. Goodbye. Game vector to array. Game map. This is my own dictionary remapping stuff. I don't need that. Build button mask. Don't need that. It's my input. Maybe some of these helpers should be shared somewhere though. I've got some good stuff. In fact, that reminds me that I'm going to need to, when I push this stuff, it's going to need the transforms change I've already made. Failed. I'm not sure if my transforms made it into the actual project. I don't think they did. Let's have a look. Here. No, See, there's no methods here. I added a few methods that I use. So in another pull request, they're stuck in pull request limbo. We have to pull those across as well. Oh, this just blows my brain up. Okay. Failed to resolve. Maybe a missing crate SG simulation. Yes, there is a missing crate. Don't need that. Don't need this. Don't need that. Oh, this definition of what a pos is required for what we're planning to do. So I'm going to just grab that pos definition. Pos. Wrong pos. Pos with a capital T. But no T in it. Capital P. Capital T. Okay, sync. I'm just going to throw the definition of a position. Where is something in space? Really? There. Use SG simulation. Use SG simulation. Use components. Use all the components. Oh my god. There's so many. So we want to create, delete, move, Godot sync, those ones, but we don't want these three. All that, all this. So many unused imports because I'm stripping things out, you see. Bridge. Don't want that. Helper, components. We'll delete the components for now. Specs world index. We'll just import pause so it knows what that is. And so by doing that it adds this line. It's one of the nice features of C-line is I can do that. Doesn't know what create components are. So wherever it sees create components, we probably want to replace that with something else, which is we called it sync. So here and here, yeah, all those places. Okay. It needs a star world link. Don't think it needs it anymore. I see, get ship nodes, don't want that. So down here it doesn't want parents, it wants one grandparent. And it wants an owner, which is passed into this function. And it wants a mutable reference to it. Owner. And so all the nodes will be created inside that owner, which is like the script. Whatever the script node is going to be the overall parent. SG simulation, lockstep. So those things are going to come out of our singleton soon. Okay, so we need to re-import this stuff. And down here. And this. Oh, have we not got an entity transform? Oh, we do. Okay, great. Yeah, stuff this up. It needs to grab them all from inside of the sink. That's so. We don't need those. Okay. How are we going with our imports? Unresolved import entity create. Let's just move this out of the screen. Entity create. Entity delete. Entity move. So, do we need to specify self now? Is that like a modern language thing I wasn't aware of? That's really interesting. I didn't know we had to add that now. But yes, rather than create, we even had to add self, which is these names. It's referring to these names here. I hadn't seen that problem before. I guess I haven't been using a my toolchain must be out of date or something. I wonder if that's just a thing in stable that's not a nightly anymore, or something similar. Just 1 second, guys. Welcome back, my friends. Welcome back to me. Yes, just saying goodnight to my lovely wife. Okay. Let's see. I was still working my way through these create problems. Use SG simulation. So we obviously don't want any simulation things because those are from my game. Failed to resolve. Okay, so this is because we removed that use Godot from before. Can't find the lazy static macro. So we did add lazy static to our cargo toml, but what we didn't do is say that it uses macros. So if we go across to here and we look in SG core, lib. Oh, it's not in this one, it's in the simulation. Lib source, lib. Where we use lazy static here, we got to actually specify that it's macro use. I don't think we even mentioned that we needed it in here yet. Lib. So GD native requires macro use, and so does lazy static. So we'll put those two there, and then the lazy static is going to work. We haven't said we want to use mutex, so use this. Let's have a look at the singleton class, because I can't remember which ones it requires. I'll put this back over here where you guys can't even see it, so you don't know how cool I am. Singleton by, well, we can pretend I'm cool, is what I meant to say, because I am doing things you can't see. Well, you can kind of see them because I made a little screen over here. Yeah, there's enough of that. Okay, run it. Okay, so we need to import your state. Your state hasn't been included in the library tree, so let's just go to lib. Whoops. Yes, we go to lib and add it here. Mod your state. So I made the your state class so that you had somewhere to put like stuff you wanted to be global that you wanted to next to world. Just trying to be helpful here. We need to register this pos, and we need to call the function register world components. We import pos. We're gradually getting there. I can see things are starting to work a bit better. Like, you know, the hints that are coming from the editor are getting better. Failed to resolve. Used your state. Once again, we need to specify where that's from. Use. The problem is that lib is not exposing your state as something public. So we'll say pub use. Maybe we'll just make these pub. That's probably easier. Pub. Which means that people can access stuff in them from other places. If you don't do that, then we'd have to like specify which classes specifically we want. Doesn't like that we put use there. So now this should go red. Or it's because it's in a macro, it probably isn't smart enough to do it. Okay, use your state, which is probably not public. Pub struct your state. Okay, proc add remove events. This will be a hook that I had before. Or something. I don't know what was a hook into. Oh yes, that's right. So it's something I need to add to the helpers. It's like a little helper that made it much easier to manage so-called component events. And I had it already in my code. I didn't really move it to something more sensible, but we'll put it in the helper file. It's just like a specs thing. I don't really want to go about explaining what this is doing right now. Specs prelude. But it's part of tracking when you modify components from the list. These little functions, a little list of things that have changed will get created for us, and that function makes it easier to manage that list. Import. This whole idea of in-ship spaces is something to create a type for Euler to make it happy. It's probably a way of making transform. Where do I use in-ship space? Only there. I mean, it's just an empty struct. I'll just put it here anyway. So in-ship space is just used to make Euler happy and help us track units. There is a way of saying don't use units. I'm not particularly in the mood to find out how to do that right now, and I kind of like have an example of how to do it properly. I don't know, maybe. What do you think? So get singleton state is the one I'm using. So we see get singleton sector. That's the only place we see it. Get singleton state, replace. So in Godot state sync we get the singleton state. The world is so this is your state, right? So if we can get state, then we get it back out. So get state of the mutex is not already locked right now. Given your state, we get world mute. Remember how we made those functions a bit earlier? And with world mute, we're going to pass that through into sync func. So whatever function gets, oh yes, that's right, I made a hook for you to put your user code in. So we call the user code function first, and then we create entities and move them to the right place and delete the ones we don't want. And we had a little hook called register scene to make life easier. I need to add another one for registering a material. A mesh. I don't have to get the example right perfect the first time. I always make another pull request that improves the example later when I've got more to add. Okay, module draw type. So these two types, create a new enum for every different thing that is in your game. I have a list of modules that you can build. I have stuff related to spaceships. And so we need to create something special, which is example scenes. Okay, so let's just make another enumerator, pub enum example scene, and we'll call this one example cube, right? And so example scenes can contain an example Z. Ta-da! So great thing about Rust is you can put values into enumerators. So in this case, this is an enumerator that contains one thing, which is another enumerator inside it. So it's like it's got a number saying, 2, which is like 0, 1, 2. So 0 would be module, 1 would be space object, 2 would be example scenes. Now technically they're commented out, so it'd actually be 0. Anyway, and after that it immediately says, okay, what is example scene? If it's example cube, 0. If it was the next scene, 1, etc. And then maybe there's some data in an example cube, like it's got a U32 and another U32 and a U16. They would also be there, right? So if you want to know more about that, look at the Rustonomicon, which is what was it just called? The Nomicon. And the Rustonomicon, this knowledge is provided as is, without warranty of any kind, express or implied, including but not limited to the warranties of unleashing indescribable horrors that shatter your psyche and set your mind adrift in the unknowably infinite cosmos. So, you might want to read that. What could possibly go wrong? Okay, we'll set the browser aside before things do go much worse. So we want to be able to create an example cube. I agree, by the way. Rust enumerators are like so awesome. They make so many things better. I love being able to select across things where there's multiple enumerators, and there's something really cute in here in entity create. Later on, you can specify. You specify in this thing called templates that are names. So I was just talking to you about making names. So you specify in a hash map what each name maps to as being an entity. So if you look at the entity, an entity could be nothing, or it could be a scene, which is a packed scene. So packed scene is a Godot thing. So it could be that a whole scene you've created, or it could just be a mesh, or something else. There's like a bunch of stuff you might want to create and put in. It could even be certain kinds of nodes, like sound effects or something, right? So you specify, although you might want to put a sound effect in a scene and then do it that way. I mean, it might be easier. Tangent. Anyway, so you might put a list of different things you want to create in here, right? How do you write code that makes those things? Well, given a particular template down here, we have something called instance template, and I use a match statement to match the values of the enumerator. And because we're using Godot enumerators, let me just fix my screen so you can see it. Let's try that again. We're using instance template, and because we're using Godot enumerators, I can make a match statement here, template. And so if it's a scene, if we found it in the map and it's a scene, then we can instance the scene. If we found it in the map and it's a mesh, we can create a new mesh instance and tell it to contain that mesh inside. If it's either we couldn't find it in the map, which is none, or it was in the map but the user told us that it was none, in both those cases we don't want anything. If any of this fails, we'll just have an empty space. Well, thank you very much. Right? And this handling here is only possible because you can have enumerators with data in them. You see how in each case we're unpacking the relevant data. Here we're unpacking a packed scene, and here we're unpacking a mesh. So, you know, it's just freaking awesome. And down here we're using another enumerator, which is the option enumerator, one of the standard ones. I love it. Let us keep working our way through these painful and slow problems. So there's no module draw type, but that's because it's specific to my game. In my game. Now, if you wish to know what my game is, you choose your, I haven't tried it in Google, I've only tried it in DuckDuckGo. You choose your search engine of choice, and you type in the recall Singularity, which is the name of my game. You'll find that link is me. This link is me. That link, not me. Also not me. Those pictures, those first two the first one is me. Not me. Not me. Not me. Not me. Not me. Okay, well, that was pretty good. I can live with that. Oh! It even has a definition. It figured out exactly what I wanted to use as my definition of the game pitch. So cool. Anyway, that's what my game is, in case you're wondering. It's a space game where you build factories. I need a pop filter, sorry if I breathe it in your face. Pause. Let's try this again. Asymmetry 3. Okay, so this is like something that you get from uslid. Where do I specify it in my other project? It's from in algebra. I wonder if I'm using... Yes, I would be because of the physics. See, the reason why I need it here is... See, in a very pure example, we probably wouldn't use an isometry 3 for this. The advantage of it is that it makes the physics easier if you're using specs physics. I'm too lazy to change all my code right now to not use that particular class, isometry 3, which would require me to change all my transform code and make it all work again. So, at least for now, let's not change it. And so we're going to need this in algebra here, like so. I believe that means we also need to say in here that we've got an external crate. Or extern crate in algebra. And in here, I'm going to need to import this. Import. Okay, cannot find global world ID. Don't need a global world ID anymore. Or a scene tree world ID. That whole concept is no longer relevant because yes, just because. Current world, don't need that. Cannot find this function, don't need this. Global sector lock. Okay, so we called it global world. Let's call it global state. State. Capital letters. So one last thing here is, because this variable is not public, you cannot actually see it from outside of this file. The only way to actually access this is by using one of these functions. So, you know, privates are good. I assume from all the compiling that something good is happening. Oh, what's happening is I changed it so it required in algebra, probably. These compiling requires little effort from me. I'll just sit back and relax. That was a very nice relax. Thank you very much for that. Okay. So we're going to need to have some scenes. So the scene we must be creating must be this one. Yes, child scene.tscn. So we're going to use the child scene as in our lib function. So in lib down here there's a ready, and in the ready we're going to populate our sync. We're going to say self.sync.load register scene, and the scene we're going to register is going to be and the path will be in the other example. So in the scene create, let's just close others. In the scene create we had one source file lib, and it loaded the scene like this. Here is the code where it loads the scene. So in this case we're going to register the scene, this one. Then we need to tell it what we're going to call that scene. I already defined the name I want. I'm going to call it template 3D name example scenes, example cube. Template 3D name example scenes. Like so. Now I think I got this around the right way. No, I need to specify the key first, then the scene path. Okay, so we got some more errors, but it's pretty minimal. I'll look at those in a second when I've just thought a bit more about creating the scene. So the scene we need to load is this one. Let's call that like so. Now in spawn 1 we are no longer going to do all this. We're going to have to grab a world, and inside the world we need to actually create this thing. So to get the world we call let's see. So have a look at our sync, Godot.state sync. We'll see that to get the world we call this get singleton state. So we go back to sync. So in spawn 1 we need to get a hold of the world like so. The reason why I use try get singleton state here is because if your code calls your code, it's possible that if you do it wrong, you'll never get a hold of the singleton state because you'll sit there deadlocking. If you try and get a mutex inside some other code that's also getting a mutex, you're going to get stuck. Note, this will fail if you call spawn 1, if you call from inside other code that already holds this mutex. Okay, so once you've got the world, we have to add a new entity. Dot build entity, I believe. Let's have a look at the specs documentation. Specs GitHub Rust. Let's try that. Yep. And in here I want to link to the book. And I need to know how to create. I think even this hello world tells us how to create one. The system, full example code. Yeah, so you use world.createEntity.with and you specify what you want in your entity. So world.createEntity.with, you need to specify that you want a pos, and You also need to specify that you want one other thing. I think you specify another width. And the other thing we want is going to be one of these, what are they called? In the sync, it's called a GD scene lock. So the GD scene lock remembers where you want to put things. Scene create, scene integrate, piece integration. So import that. So it's created with. We need to do something to get that imported. So create it with that. A position's not going to be valid, and a GD scene lock. So we're going to choose what the parent node is going to be of these things. The parent node here is, yeah, hold on. The parent node we're going to use, let's call it test cubes. So that's going to create a little spatial that's going to contain all our cubes. It's going to call the spatial that's going to contain all our cubes test cubes. Okay, so that's the parent name. There. And the next thing we need is a child name. So if you look at the code around us, we create this thing called keystring, which is the same as a child name. It's this format here. So we can just grab this and pop it straight in here, like so. And the last thing we need is a template, which is that cube thing, this template 3D name that specifies what we're going to want to create at that location. Yeah, let's leave it at that. Maybe. There's two ways to approach this. We could either create the position directly, or we could create the position indirectly. I kind of like creating it indirectly because it will show something useful to the person looking, but it also makes things more complicated. Anyway, don't do this. X and Z are very important. Yeah. So we'll do it really directly. So there's two ways we could go about doing this. I could create one component that's a position. I could specify where in Godot it's going to be. That's a simple way. The more complicated way is I could specify where I want it kind of in a symbolic sense, like on a 2D plane. And then I could write a system that converts it from the 2D representation into the 3D Godot representation. And that way it's probably way harder to understand, but it's a much better approach overall, and that second approach is how I do it in my game. But let's not do it right here. So we'll do it the much more direct way. So we've got X and Z. If you look down here, we create this vector 3 that maps X and Z. We always set Y, which is up and down off the plane, to 0, and then we move on X and Z based on these values that put it on a nice little square grid in the right place for us. Does my scene create use in algebra already? Probably does, because I think that Vic is an in algebra thing. No, it must be uselid. Okay. I think I'm going to have to translate this to uselid to make it work, to in algebra to make my existing code work, which is all rather ugly, especially for an example. Okay, so the position class, let's just have a look at this isometry. We're going to look at the position class. Here it is here. How does one create a new isometry? There's a rotation and a translation. We don't care about the rotation right now. We just care about the translation. So there's a from parts one. which takes a rotation and a translation. We do use from parts in here. We never use from parts. So how do we make pos? Let's have a look at one of our existing components that, for instance, does biped syncing. Makes a pause. Yeah. So it makes a default position. And then it changes all the angles, X, Y, and Z separately. This way. It's starting to look like I'm going to have to do this over a couple of nights. It's just taking too long for me to get this done. So the biggest challenge here is that my code in entity move is written already to transform, to change from the X and Y of an in-algebra pos, which is needed for the physics that I've been using. It's too set up for that. I'd have to modify it to use a different library, or in here I need to instantiate that library's values. Shouldn't be too hard. So pos from, what's the pos contain? Go back to pos, it contains one value in it. I think in that case we just specify pos like this and import, and then we have to specify that we're creating it from an isometry 3 from parts, and then specify the two parts. So the first part is a translation, so we need a translation. We'll probably just specify all the parts, so translation 3, translation 3D, and it would require 3 translations, which would be these 3 values here. Blam. And then we need a rotation, 3D, and the kind of rotation we want is really dull. Identity does nothing. And that's where we want our little cube to go. And wouldn't it be lovely if that just works? And then we need a GD scene lock, import, parent name, template name, blah blah blah. Need to import that as well. Oh, I see. We call it template. PLATE, template 3D name. Needs to be some to say that we did have a template. That's done, so that should be the entity we're creating. That's where it needs to go. We increase how many children respond. We forget how to remove any for now, so we can only create them. When that compiles, that should be enough. Expected function, found expected translation 3D. I probably need to specify what I want to create it from. It's probably called new. XYZ, yep, that's what it is. Unused entities res. Don't need that. Unused arc and mutex. Okay, fine, get rid of them all. Unused IO read. Great, get rid of it. Unused fetch. Yeah, let's not worry about those unused for now. The trait copy may not be implemented for this type. Okay, cool. Why not? I forgot to implement all these things for the example scene. Okay. Okay, I forgot to specify that pos was allowed to be a component. So I have to implement the component type for pos. I've already done that in here. Like so. I made it a flagged storage so we can track when they get added and removed. Where is pos? That flagged storage thing I think was required by the physics, not by me specifically. That's what tracks when things are added and removed. The trait bound sync pos component is not satisfied. Let's try it again. Okay, what's wrong? It requires a translation, not a translation 3D. Okay, so let's just say translation. Hopefully that works, and we'll remove there would be a import here we don't want. Yes. So from parts, so we need an instance of translation. I bet there are some standard ones in here. I'm trying to find a 3D one. Anyway, so the scalar is an F32 and the dimension name. Anyway, I want 3 dimensions. Is that going to work? How are we going so far? Lots of warnings about imports. We got from part somewhere. I feel like I should have a look at the documentation for this. So we want docs rs and we want NALGEBRA in algebra. And in particular we want the one for isometry 3. And he uses a U3. I see that's one of the dimensions. So what does that particular isometry need? So does that mean there's a transform 3? There is. Okay. So I don't want a transform 3, I want a translation 3. Great. So we say translation 3 new and see if that works. Okay, so it's not happy with that being undeclared. It's an algebra geometry, so let's just put that use statement in and see if it makes it happy. In algebra, so it's use in algebra geometry translation 3. Does that fix the problem? Oh, that was more yellow and awesome. And new. It expected a unit. From parts. There's a translation and a rotation. Yes, where's the unit come from? Is it a difference in version? Am I on the wrong version here? Oh, in algebra. Hold on. It's time for some moss. Come on, moss, come run my life. Okay. Um, mm, come on, we're so close, Tom. You can push through this. Let's close all these. Close this. Close that. Okay. Translation. I just need to be able to make one of these things. God. How hard could it be? From parts. Translation 3 new. The unit quaternion. Am I supposed to say unit quaternion rather than what I said? What did I say? Rotation 3D. Okay. And now I need to make sure that I include unit quaternion. I bet it's in geometry. So I just needed to read the documentation. Can you believe it? I'm getting pretty hot. Sorry about the sheen of coding. No function or associated item from transform. Yes, that's right. This is part of the code that is in my pull request, but not in here yet. How are we going to manage this problem? We're going to have to Oh. I wonder if I can do something to like stream. There's a watch link right there on my username, and I'm getting distracted by Discord now. There's a username right there in Discord, but I wish I had some way of going live on the Discord channel itself so everyone could see it and go, ooh, so shiny. I have to figure that out some other time. Don't get distracted, Tom. That's going to put people off. But hey, since we're here, we've got a Discord. Let me just paste a link to the Discord in here so that you know where to find me next time. Invite people. I'd love it if you'd come along. Invite link. Expire. Never. Generate. Copy. If you click on this, you can come talk to us, and it's a nice place to hang out and ask questions about what the hell's going on. And in addition, we'll support you when you're making your game and like look at your screenshots and tell you that you're really cool, because I'm sure whatever you make will be great. Okay. From transform. That's right. So that was code from my branch. We're going to have to pull that in. Let's have a look at me on Git. Have I got it here? Yes. Go to my repositories. Is there an easy way to see my forks? Probably in the list of forks. And Tom Lee's, that's my fork here. And branch. I've got transform helpers. That's what I'm thinking of here. So clone or download. Let's copy this link. And if I go back to Git extensions and open my Rust example, and then fetch, I need to open the pull dialog. Manage remotes. Add a new remote. The name of the new remote is Tom. The URL is the one I just copied from Git. And save changes. Yes. Whatever the hell that does. Okay, it seems to have done a pull. Get rid of this. So, fetch. And in here I'm going to set default fetch all. In fact, it's already done it. Here's my transform methods. So, we're going to make a commit. So we're going to make a work in progress commit of all the things we've done so far. So let's have a look. We didn't mean to change any scenes. So we can revert the scene create main scene change. We needed to add the cargo, all these specs integration modules, need all that stuff. So stage all of that stuff. I added a bunch of files. Okay, so whoop, add a new specs integration example. Bang. We're going to push this, and where we're going to push it to is feature. Am I using the full word feature or just the word feat? Oh yeah, I'm using feature without any kind of slash. So feature specs integration example push. Yes. Okay, so I needed to change this drop down and choose Tom here. Tom. And put that branch in one more time. Push. So I don't have the rights to push directly to the GitHub, the other repo, which is probably good because I didn't really want to. I wanted to use a pull request for that. Okay, so having done that, I have a new path. So if we go into my branches, and I go into did I call it scene create example? No, good. Okay, scene create example will be an old one then that I haven't deleted yet. Let's just refresh this page. Oh, I see, it's just told me about it. Specs creation example. Here we go. So that's a link to the entire thing. So I'm going to put it in my Discord. Here is, if you're watching and you don't want to join the Discord, you just Google for Tom Lees, which is my name. You'll find it. It's a public repo. So here is the repo for the specs integration, which is not working, which is not compiling just yet. P-A-L-I-N-G. Great. So that's the work in progress. Okay, so having made that feature branch, you remember my problem is that this helper methods is not up here in our new feature branch. So let's check this out. Check out. Now wouldn't it be nice? I think if I looked at the feature transform methods in here in the pull requests branch, we had a pull request. I'm not sure what the comments were. Let's have a look and see if because I haven't dismiss. I have an active pull request for this dismiss. Don't I? I thought I did. Go back to Godot Rust. Look at pull requests. Look at first helper functions for basis and transform. And it needs to be rebased. I did a rebase. Problems with CI. Need to support newer uslid with units. Here's better example code. Yeah. So basically no one's got any useful comments other than the fact that it doesn't pass the automated tests. So passing the automated tests also need to be fixed. I'm not going to do that right this second. So we're going to just move this so that it belongs on master, which is here. So we right click on that one and go rebase current branch on selected commit. Okay. And so what it does is it remakes all the commits and it puts them on top of master. So the old commits are still where they were. Now we're going to push, not to origin but to Tom. We're going to choose force push with lease push. And so that's moved my code up to the present. And most likely the continuous integrations are going to come back saying that that's not valid because it's messy somehow. Let's not worry about that right now. I'm going to swap back to my other branch. Check out my specs integration example. Creating a new branch with that name. Check out. So you can see this is just running Git, and it shows you exactly what commands it's typing in to the command line to run these things that I'm doing in the UI. Okay. Now that we're here, and we've got these transform methods all handy, we can just right click on this and go merge it into current branch. Merge. Okay. Hold on. Did it not make a commit for me? Is that what's going on? Yeah, it didn't do an automatic commit. I didn't realize I had that turned off. Okay, commit. So after all that carry on, we now have transforms. So if I have a look in the transform class, which is here in GT Native, it's added a new function, translate, and another new function from transform. And from transform takes it from this transform. We use this, I use this in my integrations, so it's kind of necessary to have that. And that's why we did all that merging and so on. Compile, 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 you slow computer, you. Actually, you're very fast. I don't blame you, but it's a lot of code. Cannot use owner because it was mutably borrowed. Lots and lots of import warnings. Okay. Cannot borrow grandparent as mutable because it's behind a regular reference. Grandparent. It's up here. Do I need to say it's a mutable grandparent? What do I need to do? I'm confused. Grandparent is already mutable. Do I need to say it's double, triple mutable? Like, just say here mute. Grandparent mute. I'm not sure what you do with tuple unpacking. That's, or maybe I just say that everything here is mutable. Mute. No. I'm at a loss as to how to unpack this thing. I think we just need to turn off this warning for now. So in order to turn that off, I need to put this at the top of the file. One. Oh. Am I in the wrong? No, I'm not. Okay. Lib. Here. Put sworn in. We say, instead of saying warn, we say allow. Because we wanted to affect the module that's in, we put an exclamation point there. And now we get all those yellow import warnings. But later on when we tidy this code, it'll get rid of all the old imports we don't need, so that'll fix that problem anyway. Not using default parent. Unusable variable poisoned. Variable does not need to be mutable. Okay. It probably does need to be mutable. It just hasn't realized yet. Which is weird. Okay. Cannot borrow star grandparent. Do I need to say star grandparent as add child? Specifying here that we're calling this. I'm confused. Why do we end up with a star grandparent? Maybe having a reference to a spatial is just too confusing for this program. We should probably just put a regular spatial here. And then down here we should just say add child. And then here we'll just say owner.clone. Cannot borrow self world as mutable. We need to say this is a mutable world. That's why before it was, yeah, one time I was saying I didn't need something to be mutable. It's because I didn't put the mute self there. Oh, it compiled. That's a surprise. It's always a little bit surprising when things actually compile. Okay, let's jump across to Godot. Project. Quit to project list. Yes. So from here we want to import, and we need the path to there, which is basically the path to here. So that path, plus we need to add specs integration and open that project, import and edit. It'd be nice if it works. Here it is. We'll try running this and see if anything goes. Add child. Okay, so there's no spawn one. I probably couldn't find the relevant DLL. Yeah. What did you say to yourself? Does not have a library for the current platform. Okay. So, even though specs integration compiled okay, our version of specs integration gdlib, specifically this last one, and did we end up with a different file name than what's shown there? Did it go into a funny place? Is it possible that the way I built it was strange? I was gonna run the command line cargo build for everything. Did we add something else in here? GDNS. Here we have the wrong file name again. So we don't want scene create library. We want specs integration. That name. So this gdnlib is matching the name of this file here. And down here, it's not a class name called scene create. What do we call the class? We call the class specs integration. So in here, I'll change this to specs integration. That should be enough. So if I run this again, does it find the class now? It does. It says it has a scene, so it even found the class and it ran that scene loader. So it says it called the panel OK. And something's getting called. So I think it's adding 3 children to the world. But what we haven't done is we haven't changed our Rust code to actually call the synchronization logic that we've been talking about all this time. One thing to note is that if you've watched me work on my game, you'll notice that whenever I rebuild the code after running in Godot, I have to quit Godot to do it. But in this case, I don't think we do. I think I haven't broken it yet in this project. See, I've broken it in my own project, but in a regular project, you can recompile without quitting Godot. So there's something that's wrong with my project that's causing this problem. Probably to do with the network thread, is my guess. Because threads are usually evil like that. So something useful to know is that you can recompile it here. Okay. lib.rs. What was I about to do? That's right. Inside of my frame by frame function, which is called process in Godot. So let's make one. And let's not just make one, let's just copy an example. So jump back across to my own project here, and we'll look at, for instance, ship link. We'll go down to process. We'll see that I call this function called state sync. Do sync. Like so. So I'll just copy this whole lot. Yeah. Great. So there's a process function. It calls state sync. Did I call it state sync here? No, I called it just sync. So I'm going to rename this to be state sync. And then in here, 2D module sync. Yeah, in here, this is a handy place where you have access to the world right before we synchronize it. Perhaps run your own systems here. Okay, so with that in place, let's try recompiling the DLL that Godot's going to use. That's done. And now we're going to run Godot again. Ah, it's working! It's working! Ah! So isn't that cool? So here we are adding entities to specs and then having them reflected on the screen. That's great. We can't remove them though. So when you remove them, it doesn't delete them from the screen. And the quit? No, I don't need to quit. The reason why is because remove one is not actually deleting them from it's not deleting them from specs. In order to delete them from specs, we need to know which one to delete. So what we could do is we could create a very quick class, a very quick component. Yeah, let's do that. So struct example component, right? And this is but we're going to have to create it in your state for this to be easy to do. So example component, and the example component contains one field which is its creation order. So it's creation ID, and the creation ID is going to match the type of this counter. So we've got this thing called children spawned, which is a U32. So it's going to be child ID, and it's a U32. When we create a component, we're going to put that one in. Impl, rather than doing my own implementation and trying to make sure I get it right, I'll just copy one that exists. Create. Ugh. I don't seem to have any components here. We've just got the pos. We've already made a pos component. Where's that? Pos. Your state. Yeah, it was pretty cool, eh, Wildly? Thanks for the celebration. Woo! I was pretty happy with that. That all working. If you were wondering why I just wooed, I'm sorry you missed it. I was running the example earlier. Okay, anyway. Create component for example component. Don't worry, more woos coming. How do we store these things? Well, we don't need a flag storage. We just need a vec storage. Vec storage. This is how examples components are. It's just basically a vector of them inside of specs. You get to choose. That's one of the nice things about specs. It's quite cute, really. Cute as a nice. Okay, pub. Go down to the pub and find an example component so that we can shoot it later. So down here, when we create a child, we need to also specify that is an example component. So we'll put that in here too. Dot sorry, whoops, that dot width. So in every other line we put this at the end like that, and then we put the dot width on the next line. Width, we want an example component, and example component isn't currently public. Pub. And it should go red. There we are, import. And then the next thing it should do is complain that there's missing fields. Missing fields. Child ID. It's going to be self dot children spawned. How many children have we had? And that then names which node we have. With that done, we can go down to here, and we said, cool, remove one. And the way we remove it, first we need to find the particular entity in question. The only real way to find them is to do a quick search through. So for let entities. So in order to do this, we're going to need a world. So we need these two lines of code here. Then need them down here. Then we need to look through the entities until we find our new entity. So with entities, and what's the other one called? Our component. And what are the types of these two things? Well, the first one is something called I think this is called entities. Yes. And the second one is called a write. No, it's actually a read. Read. And the type is example component. So these are the two things from specs we want. I thought I was using the prelude. I'm not. Okay, we're going to use the specs prelude. Use specs prelude star. Semicolon. We don't need this probably. Okay, so we're going to read these values from the world. World.system data. Okay, it's going to populate entities in our component, which we're going to look through. For entity component in, we're going to join these guys. So entities. In fact, I don't think entities requires you to make a reference of it. Probably does. I don't know. Anyway, this is not called our component. This is called all components or our components. Put an S on the end. Our components. Great. If component dot, and so component is like a reference to a particular one. So I forgot to put dot join on here. Dot join if component dot, and the value was called up here. We called it child ID. Child ID is equal to, and the value we're looking for is num children. Have we changed num children yet? No. I wonder if the code we deleted reduced num children. Yes, it did. Great. Okay, so num children spawn decreases. Then we find the child that has that ID number that matches the number of children spawned. Yeah? If we find that child, we kill it. Entity Q3, I think it's called. I hope so. This is a specs function I'm looking for here. Let's have a quick look at the documentation for specs. Hello world. I can't queue a free here. Looking for an entity. Entity type. I want to queue a free of these. Yeah, we need something here called delete. So we need an entities res. How do we get hold of one of these? I'm pretty sure we've queued freeze before from our other code. So I'm just going to quick look and see if I can find it. Read data.entities.delete a specific entity. So what is read data.entities here? It's this thing called entities. So first we join across it. Do we? Dot delete. So convey a entity. It's all a bit confusing to explain in this particular instance. It's not the one I want to show you. That one there is probably better. No? Oh, there's a world function to do it as well. If you know which entity you want, you can... Okay. So it should be go entities dot delete entity, and that should work. Wonder if it'll compile. It's complaining that we haven't made a default type for the example component. So there's probably a bunch of things that most components have in them that I haven't bothered to implement here. So let's just find a component here. Modules, production module. Here's a bunch of example components, things that I tend to derive for components. So we'll just whack them all on here. We don't need serialize and deserialize. Divide clone equivalent, yep, those other ones are fine. Okay, so for some reason it didn't stop and rerun. It's not implemented for what? Have you tried using Godot servers at all? If so, what are the benefits of specs over those? Just writing more pure Rust and avoiding binding calls. Have I tried using them? No. As far as I know, the things that are already low level, like the rendering server and sound server, you can get low level access to them using these servers. I've never looked into writing my own server. I think if I did, I'd be writing something very low level at that point. Like I wouldn't be using a scene tree and so on. What's the benefit of specs over them? I probably still want to use specs. The reason why I use specs is to separate the logic of your code that is talking to Godot renderer from the part that's talking to Godot sound from the part that's talking to some other thing to do with your game logic. So you're trying to break your game into these vertical slices where each one's like a module, like a part of your game, like a pillar. So in my game I've got the concept of a little thing is in a particular place on the conveyor, but then there's something else which actually embodies that it's a box and holds stuff. That's why I'm using specs, is to separate those two ideas. And then over on the side here it's like, well, what do we render that as? Render it as a box. So those things are three different components. Yeah, so that's why I'm using specs. So I think as long as I have that particular problem, I'd want to use an ECS. I don't know if I'd want to use servers, although my initial take on it would be anything for Godot is written in C++. So you'd have to like think carefully, is the API good enough you'd want to work with it all the time? Seems unlikely. Seems like you'd want to wrap it. Specs is more designed for Rust than, something which is from the API. Thanks. I don't know. Oh, that's right. I just remembered. If I say the word read here, I'm talking about something called a resource. I need to use read storage for components. Okay. Join. Need to put a reference here. Probably need to put a reference here to entities as well. Needs to be compiling. Okay. So this should iterate over all of these. For each one, it gives us a reference to a specific entity and component. So this is like an ID number, and this is the value that the other component that happens to have also an ID number in it of our own making. If we find the right one, we tell the entities that we no longer want that marked entity, and it should get deleted. Because it gets deleted, this entity delete thing should find it in this list of removed spatials, and it will go and find the spatial and tell Godot to delete the node. The result is that when I run Godot, when I push the delete button, hopefully it goes away. Okay. We're not even seeing any now. That's weird. I don't understand how that happened. I probably should have, makes me wish that I'd committed between these two moments in time. My only guess is that this addition here is somehow stuffing things up. Let's try quitting this. Quit. Try recompiling. I wish I'd made a snapshot in Git now. Run my specs integration project. I just realized I need to change the name of the project as well. This project here should say this is Go.Rust specs integration example. Run this. Add. If I look here, there's a poison, so at least there's a good suggestion. Okay, it is complaining. Why is it complaining? Because we're adding the component. Why is it complaining about us adding the component? Because we forgot to tell specs we had a new component we wanted to store. So if I went across, so this is the one called example component, and if I go across to your state, remember how we registered that we want to store pos? We need to also add one for example component. There we go, that wasn't so bad. So let's run that again. All that malarkey caused me to quit out of the editor by accident. Add. There we go. Remove. Remove does not do anything. When I try and push remove, it's panicking. Assertion failed. Left is equal to right. Left, right. Okay. Lib. This assert here is failing. Num children. Owner. Oh well, that's going to fail because it's looking at the one child. We created a single child and put everything else inside it. We don't need that code anymore. Yeah. Num children -1. We're just going to use child spawned actually to specify how many children there are. And this owner shouldn't be get child counts anymore, it should be the number of children spawned. And is expecting a Yeah, I64. So we make an I64 from this number. I64 from this I32. And down here, same thing. I64 from this I32. Here, the application's still running. This game we never quit. So we'll quit the game. We'll try and link it again. Okay. Come on, work perfectly. Add, remove. So, it's probably not finding them. Is it because they're not calling maintain? I mean, we're supposed to... Maybe that's something we need to add automatically to our sync, just to keep things in check. So, your worlds need to be maintained in order, like it's a specs thing, right? So we call the sync func like this, and then we could call world.maintain like so. That might be required, because that delete doesn't actually delete things straight away. It deletes them after maintain is called. Add. Yeah, there we go. Add again, deleting. Woo! That's pretty cool. Through specs. Oh my god, thank god that's done. I'm so ready for sleep. Okay, commit. So we fixed some naming, added some good syncing. Okay, create your state. And deleting through specs is working. Good. Probably not the best commit message. Oh well, let's push this. So you, my dear, you, my dear viewer, can jump onto Git and you can pull this down and you can have fun. Let me just make a PR for it. But it's not going to get merged in straight away. There's going to be a few problems with it, I imagine. And the next thing to do is going to be to create some friendly unit tests. Sorry. The next thing to do is to create a friendly tutorial that you could follow to use this somehow. Although it seems kind of redundant if it's actually a straight up example. Probably should just have a demonstration of some kind. What does one do? One could even have a whole stream and one created an example. If only we could do that. But it's but tedious. I mean, it's how long is it? I mean, yeah, it's pretty long now. Sorry for making you sit through it all. I hope you had fun. Up to 2 hours and 40 minutes now of creating an example. Go.rust. Let's tell them how cool we are. Specs integration. Create a pull request. Open a pull request. Added an example of using specs to control Godot creation, deletion, and moving of nodes. Use a similar system in the recall Singularity. And I think the thing that anyone who's reading the PR should read is my latest Recalling November update, because I mentioned in that update that I'm planning to make this example. Asteroid physics, different worlds. Probably this one is the best one. chip physics, laminar, network player input, generate binding between Godot and specs. Is there a way of linking this? No. Okay. Well, I guess I'll just friend link the whole lot then. Share friend link. Copy. And the way call Singularity. The example probably needs work at the time of creation of this PR. Now, the first thing we can do before we even try and commit this is we can run a tool called git fix. Cargo fix. And it's going to find a variety of problems with my code. I probably need to remove the allow as well. And with that fixed, that'll help get the PR accepted. Bindings is a bit slow. Have you seen my pretty rocks? I made some rocks in Blender. They're pretty cool. That was like some time ago now. And then I went on and made them all like pretty with textures and stuff. Here's like a version where you can like shoot at them with a little spaceship. Pew 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 pew. And I also use the same rocks on this little demo of refining things. Okay, so this fix, I think it's made us some stuff to commit. Yes, so it's made a bunch of little changes, variables we haven't used and so on. I thought it was going to fix our imports as well, but if we stage all these, we'll have a more likely to pass cargo fix. I'm more likely to pass the PR because I'm pretty sure they do an automated cargo check like that to make sure the fix has been run. Push. I probably need to remove the allow bad imports as well. If I remove that, I wonder if it will cargo fix will fix them. Lib. Remove the allow imports. Go back to the console, run cargo fix again. I need to stage commit stage those changes. Hopefully it's faster this time. Yes, it's stripped out the imports now that I'm no longer allowing them, which is exactly what I wanted. So I'll stage those as well, and I will amend commit and commit that. Yes, rewrite history, I don't care, I'm going to push to a different branch. Well, I'm going to force push. Okay. We're reaching the conclusion of our scheduled programming very shortly. Push. Options, I need to force with lease. Push. To allow me to change what the head of a branch is. Okay. Create pull request. And it's busy at the moment running a bunch of tests. There's a continuous integration test that's running at the moment, which is really great. So there's a pull request. Let us all celebrate the creation of a pull request so that our favorite library can grow richer and stronger. PR. It's working now. So this is probably worth mentioning also in the Go.Rust channel. Is a specs Go.example MIT licensed to be merged with Go.Rust. Ta-da! Enjoy, my friends. Hooray! I'm going to call that a night. And thank you so much for joining me on this journey. Tom, I think you should make sure you jump into our Discord and say hello. We'd love to see you there. And anyone else who's watching who'd like to do that. If you are late joining, feel free to rewind the video. Everything's logged and watch it again. Good night, everybody. Thank you for joining me. Now I shall find the famous button that ends the stream. This one here. Stop streaming. Good night.